So now that we've seen some code, how are these things actually used? Well, a weak reference. This is often used in conjunction with something called a weak hash map. And we'll see an example of this in a moment. And we use this to associate metadata with another type. Now the metadata here could be just some data we want to associate with that type. It doesn't have to be real metadata. It might just be extra data we need to add to the type. For example, if we have a type that's marked as final, so we can't extend it, but in certain circumstances we'd like to extend it and add extra fields to it, then the weak hash map and the weak reference provide us with a way of doing that. And we'll see that in a moment. As we said, to do that, we use something called a weak hash map. The soft reference, an example given for this is caching. And people will often say that you can use a soft reference to cache things in memory. The idea here is I load into memory some large object, maybe an image, or some object that's expensive to create, maybe something I need to go to the server to get. I have a strong reference to it, and I create a soft reference to it. When I no longer need the object, I can set the strong reference to null, but the soft reference is still around. And what this means is I can easily retrieve this object if I need to by going through the soft reference. If there's any memory pressure, then this object will go away, and the soft reference, when I call get on it, will return null, as we've seen with the weak reference. And finally, there's a phantom reference. And this is probably the least used of these reference types. This basically allows us to interact with the garbage collector. And we can use this to monitor when an object's being collected and maybe do some extra work when that object is being collected. This allows us to interact with the garbage collector. And we can use this to monitor when an object's being collected and to do something when that object has been collected. And if this sounds just like the use of finalize in Java, then essentially that's what you use a phantom reference for. In places where you might use finalize, instead you could use phantom references. And again, we'll see an example of that towards the end of this chapter. So before we go on and take a deeper look at weak references, so we hold a soft reference to an object as well as a strong reference. Once the strong reference has been cleared, the soft reference is still available. So the object can be retrieved by calling get through the soft reference. And people promote this as a way of doing caching in Java. Be aware, however, in many circumstances, this is not a great mechanism. The problems with this are that we have no control over the cache. You have no control of the cache aging. You have no control of when things leave the cache. You have no control over caching with a least recently used list or a most recently used list. It's all managed by the garbage collector. So while soft references can act as a simple cache, they're not great as caches in general.